Welcome everyone to the MQ stream, and as a follow on from Jamie's excellent presentation, we have a talk by Matt concentrating on what's new in MQ for zOS. The session ID is 1AN, and please leave your feedback at the end. Questions you can post in the chat room and Matt will pick them up at the end of his talk. And over to you, Matt.
Thank you. So good morning, everyone. I hope you're enjoying the conference so far. My name is Matt Lemming. I'm the architect for MQ for zOS, based at IBM Hursley, or normally based at IBM Hursley. And in fact, I'm in the office today because we started to open up. So, this session is basically quite complementary to what Jamie did an hour or so earlier. There's probably a little bit of overlap of content, but I am going to be focusing in on things that are relevant to MQ for zOS. So that's things that are either, very zOS specific, and there's a whole load of capabilities that we've delivered in the last, few years that are very zOS specific. And then there's things that are still relevant. So, client enhancements, things like the MQ console, all that sort of stuff. I'll talk about those a bit. But, this is definitely a zOS side of things. I suspect you've already seen, I don't know how many of you went to Jamie's session versus this one. And if you went to Jamie's, you probably already saw this slide. And really what we're trying to say here is MQ is everywhere, and we're all about connecting your applications together regardless of where they run. And of course, traditionally they were all running on-prem on a variety of different platforms, and over the last 5+ years, that set of platforms has expanded very, very rapidly to include a wide variety of clouds, containers, managed containers, so things like Red Hat, OpenShift and Kubernetes, and of course as a service environments as well. And MQ plays its part in all of these. And from a mainframe perspective, which is obviously where I'm very focused, so I'm in the on-prem side, we see lots and lots of customers, and in fact a growing number of customers, connecting into zOS from outside the data center. It's now got very common for customers to connect directly into zOS with cloud-based applications. So they connect in as clients. That's growing a lot. And we also see customers running their applications on cloud, connecting into a distributed on-cloud queue manager, and then still needing to get their data into or out from the mainframe as well. And so gluing together those cloud queue managers into the MQ and zOS queue managers and getting a reliable transport in that way as well. So, zOS is definitely not an island from an MQ perspective. We see connectivity from everywhere, all across the different environments shown in this picture. And that's a trend that's, not showing any signs of slowing down. So, this picture really shows it all. That the big arrow going from the left to the right is really a common pattern for us. And that's, and that's exactly what messaging is for, connecting your applications together. And that's what we've been doing for, 25+ years. So this slide is a little bit of an eye chart. I'm not expecting to look at this in any detail, but what this shows, each box is a piece of discrete capability that we've added to MQ since the 9.1 timeframe, so in the last 3 years or so now. And the bits with the red box around them are the things that are relevant to MQ for zOS. So these are, like I said at the beginning, either specific zOS capabilities or capabilities that are still relevant. So things that run on distributed but can connect into distributed into zOS. And you can see that actually the good news is we are continuing to invest into zOS and have things that are relevant to the zOS side of things. And I should say this slide is probably a little bit out of date. I ran out of space to put new boxes on it. There's more stuff here that is relevant to the Z side of things than when I first put this slide together. So that's really good news. There's lots of exciting stuff being done recently, and there's lots of exciting stuff coming up, which I can't talk to you about. But if you do want to hear about that sort of thing, then either stay tuned to future conferences or join our beta call. And if you're interested in finding out how to do that, the MQ beta, then let me know. So let's start actually talking about some real concrete stuff. And some of this you might have heard about before, because obviously when we deliver function in CD releases, that means it drips out over time. But what I'm really looking at here is function that's in either MQ920 LTS or also enhancements we've made in the CD releases from that point on as well. And so the first one I'm going to talk about is Z Hyperwrite. So Z Hyperwrite is something that's been around as a concept for actually quite a while now. And originally it was added for DB2 support. And the idea here is that many customers use PPRC or Metro Mirror to synchronously mirror their disks and get resiliency at the DASD layer. And when you write to a disk that's been mirrored, the traditional approach was you write first to the primary disk subsystem, and then PPRC synchronously mirrors that to the secondary storage subsystem, which means it all happens in series. So you do the first write, and then the second write happens under the covers, and then when that's done, the whole write is done, and you go back to whoever's doing the write, which MQ, for example, or DB2. And that's great. It gives you resilience at the disk layer, but it does increase the duration of your writes, which means you're actually slowing down mainline performance. And particularly in the DB2 case and the MQ case, the real concern is you do not want to slow down the logging task, because that's the thing that affects how fast you go if you're doing persistent messaging. And so the idea of Z Hyperwrite is that rather than having those writes being done in series, it actually pulls up the layer that's responsible for the writes into the zOS LPAR and actually does the writes in parallel. And that's kind of what's shown here. So Z Hyperwrite, you do the write to the primary and write to the secondary disk in parallel. And basically it means that on average, you can imagine like your IO latency, the amount of time it takes to do the write, it's actually approximately halves, but it does depend on where your disks are. So like I said, this was originally done for DB2, and a while back in 9.1.2, so the CD release where we first added support for this, we then added support for Z Hyperwrite with the MQ logs. Okay, and we've only got it for the MQ logs because they're the things that affect throughput the most. If you've got slow logs, you've got slow persistent throughput. So we don't need to worry about it for page sets or things like that, just for the logs. So this is something that's very easy to switch on. There's a switch, you flick in MQ, and then you need obviously your PPRC environment set up, and you have to make sure the volumes that your MQ logs on are mirrored with PPRC. But then PPRC, and there's a couple of other bits you switch on, but actually it is quite easy to set up. And we tend to find that most customers who've got MQ also have DB2, and because DB2 had Z Hyperwrite first, most customers are already experienced in setting up Z Hyperwrite, so the act of exploiting it on MQ is quite cheap. And what's interesting at the moment is now we're seeing customers actually start to go into production with this. So this is something that, like I say, came out in 9.2, which would have been last year, middle of last year, and now increasing number of customers are moving or have moved to 9.2, and they're starting to pick up new functions. So I've spoken to a number of customers who are actually using Z Hyperwrite in production. This is kind of this bold bit down the bottom, and they are using MQ plus Z Hyperwrite, and they're seeing their log IO times basically approximately half. Sometimes it's not quite half, sometimes it's more than half, but they are definitely seeing reduction in log IO latency, which is showing that actually, this is a good thing to do. And an interesting part of it is that, originally I was always thinking that you are most likely to get this halving where your primary and secondary storage subsystems are actually kind of equal distant from the zOS LPARs. Actually, we're seeing the halving even when there's a reasonable amount of difference. Like, you might have one set of DASD close and the other one, say, 6 kilometers away. And even in that case, where you've kind of got an asymmetric setup, we are still seeing the close to halving of log IO latency, which is an entirely good thing if you want the benefits of disk mirroring, and why wouldn't you, but you're worried about the constraint on logging performance. So this is a really good capability, and I definitely recommend people have a look at it as you go on. So moving on, I'm going to talk about a number of security related enhancements to MQ for zOS. And the first one of these is to do with advanced message security. For those of you who don't remember what this is, advanced message security is kind of an add-on capability to the zOS, the MQ for zOS product, as part of the advanced advanced VUE product set, and it basically gives you the ability to have end-to-end encryption without doing any application changes. So, so lots of customers have had applications that they've been running in production for multiple years, and when they started running, the requirement for security around encrypting your data that you're sending was less important. That doesn't mean you shouldn't have encrypted, it's just that there was no strict legal requirement to do so. Increasingly, over the last few years, and GDPR and HIPAA and all these sorts of things have encouraged this move. We're seeing customers wanting to encrypt their data as it's moving through MQ, and doing things like TLS for encrypting the data over the channels just doesn't cut it anymore. What they're looking for as a requirement from their either their business or from regulators is actually to encrypt all of their data all of the time. And advanced message security gives you a way of doing this by getting the queue manager or the MQ client to automatically and transparently encrypt and or sign message data at the point when it's put until a point where it's gone and destructively got at a later point. And the value here is that that message, once it's encrypted at put time, is basically routing through your MQ network entirely encrypted until the point when the end getting application goes and gets it. So that means your message is encrypted in the queue manager memory, when it's written down to the log or page set, when it's sent over the network, although you should still use TLS over network hops, and also on intermediate queue managers as well. So if you go from Z to distributed to zOS, your message is encrypted for that entire journey. And an increasing number of customers are using this. What we have had a number of customers looking at recently is actually environments where some part of the environment has a requirement for AMS and the need to do total encryption, and other parts don't have that requirement or perhaps don't have that capability. So this is very common if you're dealing with business partners. So you might find that one business requires that all of its data is encrypted, so they use AMS inside the business when using MQ, but they have a need to send data back and forth via MQ with business partners, and that business partner might not have the same level of requirement for data encryption, and that is typically where we start to see slight challenges, because you've kind of got this mismatch in terms of encryption requirements. And an obvious answer is, well, get the business partner to start encrypting their data, and that's a reasonable requirement, but it doesn't mean that they then have to make sure they have entitlement to use AMS, and it's not part of the core product, it's part of the advanced or advanced VUE offerings. And so in the 9.1 star CD releases, which is now part of 9.2, we have the ability to kind of bridge those gaps. And what that means is actually the part of the organization that requires AMS inside their organization can have it, but they can then deal with the alternative, outside organizations that don't have a need for AMS or perhaps don't want to purchase it. And so what we've done is provided the ability for channels basically to remove or apply AMS protection as messages flow through them. So if we give you an example, if an organization has an AMS requirement, that means that all the messages moving through that organization are encrypted. But when those messages transition from that organization to an organization that doesn't have AMS support, then MQ will automatically decrypt the message before forwarding it to that other organization. And the inverse is true as well. When a message comes in that isn't protected by AMS but needs to, because that's what that organization's particular requirement is, will automatically encrypt it on the organizational boundary as well. And here I'm talking about at the sender receiver channels on that organization. So a number of customers have been asking for this, I'm not sure yet if anyone's picked it up, but it's definitely, there should you want to. And I know customers are thinking about this because it's very, very common to use MQ as a way of routing data back and forwards between different organizations. So carrying on with the encryption theme, I want to talk about dataset encryption. So AMS is all about, end-to-end protection of your message data from the point when it's put to the point where it's got. But obviously, if you look at a single zOS queue manager, there'll be various points where we have to write down onto disk our data. And if you're looking at the general need to protect your data, another way of saying you want to protect your data is to say, well, I'm not so worried about the data that's in memory. I'm more interested in the data that's on disk, because someone can go and read that potentially. If you've got a rogue administrator with access to the disk, they can go and read the data that's in the DASD, and that might contain some secret of some form. So, to address these sorts of concerns, in 2017, so a while ago now, zOS added support for policy-based dataset encryption. So the idea here is you don't have to worry about at an application level that you want to encrypt your disks. Instead, you apply a policy that says anyone using these disks or this set of datasets, when they write to that dataset, that data will automatically be encrypted. And when they read from it, that data will automatically be decrypted. So it gives you encryption of data on disk without your application have to worry about doing the encryption and decryption work. And so from 9.2.0, it's now possible to make use of this policy-based dataset encryption for all of our datasets. So if you think of a zOS queue manager, we have the Bootstrap datasets. They've been encryptable using policy-based dataset encryption since 2017. The archive logs, which is where your message data is going to be, they've been encryptable since policy-based data since 2017 as well. But we now also support the page sets, the active logs, and SMDS being encrypted as well. And so what this means is you can basically create one encryption policy for your entire queue manager and all of its logs, page sets, SMDS, etc., and that transparently means your data is encrypted when MQ writes to the disk and decrypted when it reads from the disk. And of course, you can apply that across a whole queue sharing group as well, for as long as they're all at the same level that supports the dataset encryption policies. So, another option, what we tend to see with security is customers have different needs, and that means they look in different, towards different directions for solutions. So some customers might want dataset encryption because they're only worried about data on disk. Other customers might want AMS because they want an end-to-end solution. And I think it's quite useful to have something like this slide where we actually look at a comparison of what all these different things mean, because actually there's quite a few different options here. We've got TLS, network level encryption. That really is only protecting your data on the network, but it is transparent to applications. We've got dataset encryption. That only protects your data on the disk, but that is actually a very common request. And again, it's transparent to applications. We have coupling facility encryption, which is protecting your data when it gets written to the coupling facility, so shared queues, benefits here, again transparent to the application. And then lastly, we've got AMS, which kind of ticks all of the boxes, plus a few other ones where it protects data in memory. So if someone goes and dumps your queue manager, they can't see your message data. And also it gives you an end-to-end hop, which is actually very efficient because it's encrypted on put, decrypted on send, and then it can hop amongst any number of queue managers. So just coming back to the performance side of things, I will say that AMS is more efficient than dataset encryption because AMS does the encrypt once, decrypt once approach. If you send your message through 5 queue managers, we encrypt on the first on put to the first queue manager, and we decrypt on get from that last 5th queue manager, and that is way more efficient than with dataset encryption, where basically every time MQ writes to the dataset, that's an encryption, and every time it reads from the dataset, that's a decryption action. And so that means that potentially for a single message, now if you think about a single persistent message where we might log it, well, we will log it, so that's an encryption action. If it then gets written to page set, that message data gets encrypted on the page set, right? And also there's encryption and decryption when we archive that log as well. So we have to read from the log, so that's a decrypt, and we have to write to the archive, so that's another encrypt. So actually Data set encryption is very simple to set up. It's a simple tick and all your data is encrypted, but it is less performant than AMS. On the converse, AMS requires a bit more thought about setting up because it's done on a per queue basis rather than a blanket switch to say encrypt all my data, but it is way more efficient because we encrypt once and we decrypt once. Plus it gives you extra benefits like I show in this table. So it's just worth bearing in mind, lots of different options, and it really depends on exactly which set of boxes you're trying to tick as to which ones you choose. I'm just going to have a quick check to see if anyone's asked any questions. No questions so far, so I'll just grab myself a drink of water and then move on. So moving briefly away from security for a moment, another thing that's been coming up a lot recently is zOS container extensions. So this is a new function with zOS 2.4 the other year, where it allows you to run Z-Linux applications in Docker directly on a zOS LPAR next to your existing zOS middleware. And normally what customers use this sort of approach for is they want to, they've got some Z-Linux application that they want to have interact with their zOS middleware to solve a particular application problem. And rather than have to have a whole Z-Linux partition and worrying about IFLs and all the things that's required to set up Z-Linux, you actually just want to have this very targeted solution specific environment just to kind of solve this particular problem. And zOS container extensions is a really good way of doing this because it's just a specific way of getting you a bit of Z-Linux exactly where you need it. And so, when you run ZCX, it runs next to your middleware. It talks to them over the network via a very fast in-memory network, and it runs on zip. So you don't need to worry about IFLs. It doesn't run on GPs and all those good things. So from an MQ perspective, there's a number of interesting options. Probably the one that's most interesting to most of our customers is a client concentrator. So here, we've got lots of customers who connect client applications into their zOS queue managers, but there's always a concern about the CPU cost of connecting client applications directly into the zOS, the MQ for zOS Chinit. Okay, now some customers worry about that more than others. Some customers don't care about it at all. But for those customers who are very CPU conscious, a common approach is to have a client concentrated queue manager, which is kind of what I'm showing on the right-hand side here, where you have a distributed queue manager running somewhere, ideally, perhaps on Z-Linux, so it's close, and the client applications connect into that Z-Linux queue manager, and then the messages are forwarded from the Z-Linux queue manager to the zOS queue manager via sender-receiver channels. So that model is quite common, perhaps becoming a bit less so, but it's still quite common. Now, what you really want to do is bring that distributed queue manager as close to the zOS queue managers as possible, because by getting it close, you're reducing latency, and you're making it easier to manage the whole environment as a coherent single thing. That distributed queue manager is really only there to go with the zOS queue manager. So you want it as close as possible. And ZCX is perfect for this, right? You can't get any closer than running on the same zOS LPAR. The network connection, the sender receiver channel bit of the picture is done in memory, and is therefore super fast. So this is a really, really good model. So if you are doing client concentrator, maybe with an appliance or a distributed queue manager, maybe a Z-Linux queue manager running in a Z-Linux LPAR, this is definitely something to think about as a way of kind of making your environment faster and smoother and easier to manage as a coherent whole. And there's a couple of other scenarios. The fast gateway one I'll come back to in a minute. But this is definitely the most interesting one. And there's a couple of red books written about ZCX, and there's a link down the bottom, and this scenario is in all of the red books. So a couple of other things here. Like I say, we're seeing increasing number of customers move to 9.2.0, but a lot of customers haven't done it yet, or maybe they're going to wait till the next LTS release comes out. What I did want to talk about here was like quite a big change we did in 9.2 LTS, where we actually made the backwards migration approach much simpler. So if you recall how backwards migration works with MQ for zOS, or used to work with MQ for zOS, so if you went from 9.0 to 9.1, then before you make that transition to 9.1, first you apply migration and coexistence PTFs to your MQ90 environment. And that then allows you to go forwards to 9.1. And should you decide to at that point, you can then switch back to MQ90. If something goes wrong at the 9.1 level, you can go back and do a backwards migration, but you had to have those migration and coexistence PTFs installed first. And the reason you had to install those is because it allowed the older, the back level queue manager to understand the newer queue manager's disk formats and kind of dealt with the difference of in how data was stored on disk between the releases. So, that approach has worked for many, many years. However, it was becoming increasingly painful. For example, one thing that we always saw was the migration and coexistence PTFs were something that we got to after, or started working on once we'd got to the point where the LTS release was done. Obviously, we were busy writing LTS release code, and then we had to start thinking about the PTFs. And that means there was a delay in time before they come out. So, your LTS would go out, and then a number of months later, the PTFs for the earlier releases that you need for backward migration would come out. And then, those PTFs would be available, but they'd take time to make it into an RSU. And then it would take a while for that RSU to become part of the quarterly RSU, and then there'd be a delay in the customer picking it up. And that meant that actually, when you put out, say, MQ91, it was about at least 6 months before the customers were even ready or able to pick up those PTFs, because they hadn't been into a proper RSU by that point. It also makes it harder for us in continuous delivery. So we're continually bringing out new pieces of function in every CB release. And we need to make, really, we should be doing the backwards migration work as part of the function. And because there's a PTF, we kind of couldn't keep that PTF open for ages. So we had to do the backwards migration as a separate step later. Now that's all changed in 9.2.0. So from 9.2.0 onwards, so, that means future LTSs as well, we no longer need backwards migration PTFs. Instead, what happens if you want to go from 9.0.0 to 9.2.0, then you just switch over your libraries, start your queue managers up, and that's you done your forwards migration, okay? In the unlikely event that you do need to go back from 9.2.0 to an earlier release, then what you do is you shut down your 9.2.0 queue manager cleanly, and then you run a command that basically says, go and look at your data and rewrite it so that it's in a format that's suitable for that earlier version of queue manager. And that's done via the start queue manager backmig command I've got in the middle of the slide. And so, that consists of the queue manager coming sort of halfway up, reading its data in, adjusting it, writing it back, and then it shuts down. At that point, you can switch your load libraries back to the earlier version and carry on running. And I should say that, this is actually quite a quick operation. There's not that much data we need to write. There's just a few bits in some of the page sets. So, running that command is normally an act of a few seconds. It's not something that takes hours, it takes seconds. So if you do need to go back quickly for whatever reason, it's something that's pretty instantaneous. But it is a much nicer solution than what we've had in the past. And the feedback we've had from customers so far is they much prefer this. It allows them to get going much readier, more easier. So I should also remind customers that in terms of backwards migration support, if you want to go to 9.2.0, then we support backwards migration to either 9.0 or 9.1.0. Okay, and we don't support backwards migration to CD releases or version 8, but that shouldn't be a surprise. That's kind of our existing policy anyway. All useful information to be aware of. Right. So a couple of other install changes. Now we're talking about the SMP side of things. We've been trying to make our installation process for 9.2 as simple as possible. And in order to do that, we've kind of been getting rid of extra SMP requirements. So it used to be that if you wanted to make use of AMS, there was an AMS enablement module which you had to install separately and put in your steplib, and the same sort of thing for VUE as well. There is now no requirement for either of those. Instead, you tell the queue manager what entitlement you've got, and if you say you've got AMS entitlement, it will trust you and allow you to switch AMS on. And then when you've enabled this function, that will get put into SCRT records and validated at a later point. So, this is now much simpler to set up things like AMS or VUE. because we have had a number of customers saying it gets a bit confusing knowing which bits they need to install and what they need to set up. It is now much clearer. On a similar vein, it used to be that if you want to make use of the managed file transfer piece of the product, you used to have to go and install that separately via a completely different SMP install. Again, that's now been moved into the base set of SMP libraries if you're entitled to it. So if you're entitled to it, you switch them on and say, I want to install MFT, and it's a much more seamless install step. One other thing we've done in this area is we've seen, so MQ has now supported continuous delivery releases for about 4 years. And on the distributed side of the product, we see quite a few customers actually running with continuous delivery releases because it fits with the way they want to do their upgrade model. On zOS, it tends to be that most customers use the long-term support releases because they want that really stable environment. They don't have to worry about picking up updates every 4 months or every year or something like that. But some customers are looking at CD on zOS, particularly those customers who want some of the new functions sooner rather than waiting for the LTS release. And so what we did for 9.2 is actually make that easier for them to upgrade. So basically with CD releases, you can either have a completely new SMP installed for every CD release, or you can hop from one CD release to the other by applying a PTF. And it's quite a large PTF because it basically replaces the whole queue manager, but it's still done via a PTF rather than SMP install. And some customers are complaining about the fact that, well, sorry, getting ahead of myself, what used to be the case is that those PTF upgrades were only possible if you were going from inside an LTS boundary. So if we look down the bottom, if you go from 9.01 CD to 9.202 CD to 9.4 CD, that could be done via PTF. But once you got to going from 9.04 to 9.1 LTS, or 9.04 to 9.12 CD, those had to be done via SMP installs. And that was kind of a bit of an upgrade barrier for some customers. So what we've done from 9.20 LTS is give you the ability to choose from a CD set of SMP libraries or an LTS set of SMP libraries. And if you want to upgrade through CD for the foreseeable future, you can just do that via applying PTF. So you can go from 9.20 CD to 9.22, 9.24 when that comes out, 9.3, etc., and your upgrade is basically just by applying PTFs. I would say it's worth bearing in mind that because these are just PTFs, they get picked up in RSUs. And so from 9.21, we have hold data to prevent accidental migration to the most recent CD release, because again, that's caught customers out as well. But should you want CD releases, it's worth bearing in mind that they are now much simpler to get on and stay current with. And of course, CD releases from our perspective, when we're developing these things, CD releases are treated just the same as LTS releases. They get the same level of advanced testing, they get all the same care from documentation and making sure we've done the right thing and all that good stuff. So there's no real reason not to use CD releases. It's just, a number of customers aren't interested in picking up changes that rapidly. Couple of things on prereqs, basically we support all the most recent versions of middleware, so zOS 2.3 and later, DB2.12 and later, Kix 5.2 and later, and IMS 14.1. Java 8, that's the level of Java we support on zOS at the moment. So hopefully none of that will come as a surprise. And obviously as things evolve, new versions of different pieces of middleware come out, we add support for those as we go too. So now I'm going to kind of move towards some of the bits of slide where that are a bit more cross-platform focused. Okay, so these are still relevant to zOS, but there's a few things that are a bit of cross-platform. And I'm going to start off with the FASP gateway. So for those of you who don't know what FASP is it's basically another network protocol. It's different from TCP/IP. In fact, it's based off the UDP way of doing networking. And the idea of FASP is it's designed to be highly optimized for transferring data over long distances, okay, and be way more efficient at it than TCP/IP. So TCP/IP is obviously a really good, reliable protocol, but it does suffer over long distance lossy networks. So if you lose a packet, then what happens is TCP/IP will detect that a packet's been lost, and it will slow itself down. Okay, so you might be sending data at high speed through a network, but you lose a packet. TCP/IP will detect that, and it will resend the data. So you don't lose your data, you just end up with a delay in it being moved. But because it's detected a packet loss, it assumes that actually the network is getting congested. Okay, and that it's sending data too fast. So it will slow down how fast it's sending that data, even if it doesn't need to. And then it will take a while to ramp back up to the point where it was going as fast as it was before. So if you do have a lossy network, what you can see, if you're looking at your TCP statistics, you can see data going really, really fast, and then a packet being lost and being resent. And then there's kind of a curve going upwards as TCP/IP throttles the data and then gradually speeds up over time until it gets to as fast as it was before. And if you're regularly using packets, you get a real sawtooth picture where it kind of goes fast, slow, gradually ramp up to fast, go slow again. And basically you can really, lose the amount, or heavily throttle your network and get nowhere near the actual speeds you should be able to get. So FASP is designed to kind of prevent this sort of problem, and actually, if you do lose a packet, it just resends it and it carries on and it assumes everything's fine, and actually normally it is. So if we look at if we talk about why this is relevant for MQ, MQ is all about connecting applications together regardless of where they're running. And some customers have their applications close together, but other applications, other customers actually cross continents or the world with MQ. So, a really common example is customers in the US running one data center on the East Coast and replicating their data perhaps via QREP, or just sending their data to other applications, on the West Coast. And so, that's a long distance. We also see customers doing similar things across China, or in fact, between Europe and the US. So, lots of data is being routed by MQ over long distances. And when you do this with MQ channels, of course, they're doing it via TCP/IP. So while MQ is not doing anything wrong, if you get a packet loss, then that data being sent via MQ will suddenly start slowing down. And that can cause problems for some customers when they want their data to be over the other side of the world as quick as possible. So what we now ship, and we have done for a little while with MQ, is ship something called the FASP gateway. And the FASP gateway is basically something that you get as part of the MQ Advanced or MQ Advanced VUE entitlement. And what you can do with the gateway is stick it next to your queue managers. So you can see down the bottom, I've got a picture of a queue manager talking to a gateway that's very close to it. Okay, so same LPAR. And that means you've got a short TCP/IP hop of, probably microseconds latency, and then you do the long hop from one side of the continent to the other continent in the FASP IO data format, and then on the other side of the continent we put another gateway which switches the format from FASP back to TCP/IP and then passes it on to the local queue manager. And by doing this, most of the time, the bit where the latency and packet loss is going to occur is going to be between the two gateways, and FASP deals with it way better than TCP/IP. And if we look at the picture on the right, you'll see what I mean by way better. So here we've got a number of different scenarios where the red columns are just using TCP/IP, and the green columns are using the FASP gateway. And in both cases, we're using MQ channels to transfer 200K messages over a certain amount of distance. So in the first column, this is basically showing you this is what happens if we've got no latency and no packet loss. They kind of get the same level of performance. But once you start to add network latency, and particularly once you start to add in packet loss, you can see that TCP/IP moves much slower, right? Because it's doing this throttling I mentioned and retrying and all the rest of it, whereas FASP carries on going pretty fast, even when it's getting a 0.5% packet loss. So that's quite, every 200 packets you send, you lose one. FASP has to resend it, but actually it still goes really, really fast. Whereas TCP/IP, goes way, way slower. So if you do have any decent amount of latency, and in particular if you've got packet loss, you should be thinking about using FASP when communicating between queue managers over a long distance. And I should mention that this is a really, really good use case for ZCX with MQ for zOS, because you want that gateway to be as close to that queue manager as possible, to shorten the TCP/IP hop. And if you put the gateway in a ZCX container, it's running on the same LPAR, which means the TCP/IP hops are basically a short in-memory network, right? So most of the distance is over FASP, and basically you're kind of doing FASP to FASP with pretty much no TCP/IP at all. So it's really, really good for performance. So well worth looking at if you do have this sort of problem. So moving on a bit, talk about some managing stuff. I'm just aware that I've got 20 minutes left, so I will make sure I keep talking at a reasonable pace. I want to just briefly mention a recent enhancement to the Z Anomaly Analytics product. So this is basically a piece, and this isn't part of MQ. This is another zOS product. It used to be called IBM Z Operational Analytics. And the idea here is that this product will take SMF data from a set of subsystems, and will basically, you can train the product to understand what's normal for your subsystem. So you provide it, say, 2 months of training data, saying that this is what's normal for my DB2, this is what's normal for my KICS, and now this is what's normal for MQ, and it will build a model of what to expect over time for your environment. And once you've got that model built, you basically then switch to normal running mode, where you basically push real-time or close to real-time SMF data into Z Anomaly Analytics, and it compares it against the model and scores it. And it looks for deviations. When it starts to, when your environment deviates too far from the model, it will start to generate alerts and tell you that something's in the process of going wrong. So it might say, "Ooh, I've noticed your page set IO pattern has deviated from normal. You might want to look at that." Or, "Ooh, I've noticed your buffer pools have got much bigger than they were, or much more heavily utilized than they normally do at this time. You should go and look at that." And so it's a really nice way of understanding what's normal for your system and spotting when you're deviating from that normal without you having to do it. The tool does it for yourself, does it for you. And so, originally MQ wasn't in this environment. As of last month, or actually, sorry, 2 months ago now, we've now got support for taking MQ SMF 115 IR statistics and putting it into Z Anomaly Analytics. And there's a whole load of other things we're going to be doing in the future in this space, because I think it's increasingly important for customers to totally understand what's going on in their mainframe, and rather than them having to spend all their time figuring out whether something's right or wrong, actually tooling doing it for you. And Z Anomaly Analytics does a really, really good job. So if anyone's interested in more information on that, do let us know, because we've been talking to quite a lot of customers about it. So other things, this is where we start to get a bit more cross-platform. We've got JSON CCPT support for connecting into MQ, just making it easier to go and connect into your queue managers. And this is supported by all MQ clients, including those clients that need to connect to zOS. So I'm just going to mention this is there. The new web console. So for those of you who've not tried it, the MQ console, or the web console, is basically a browser-based way of connecting into MQ and seeing what's going on and configuring it. Okay, and this is kind of provides equivalent function to MQ Explorer, which many customers use, but it doesn't require you to install anything on your laptop. Instead, you just need a browser, right? So you'll have that, and you install a console capability on your MQ environment, and you point any number of admins or developers at it, and they can all interact with your queue managers in a secure, controlled way. It doesn't have quite all the capabilities of MQ Explorer, but it does have most of them, and we've been enhancing it over time as well. And the most recent enhancement, IN923, is actually a way of having a centralized one of these. So previously, if you wanted to use the console, you had to install it basically on each different environment where it would work with a local queue manager. Now from 923, you can install it in the central place, which may or may not have queue managers, and it will connect as a client to, or can connect as a client to, all of your MQ real estate. So it can connect to distributed MQ and zOS MQ, and you can manage them using the same pane of glass. So a nice enhancement there. And of course, this is something that we're carrying on working on day in, day out to kind of bring extra features to it, because we know lots and lots of customers are interested in it. So REST API enhancements, probably Jamie talked about this. So, you know, we now have a REST API. We've had it for a number of LTS releases now, and we're increasingly seeing customers actually doing their scripting via REST APIs, because you can do REST commands from anywhere. So rather than having to use an MQ client for PCF support or to use things like run MQSC, instead you can squirt a REST command from anywhere, whether it's Node, command line, C, Java, you know, name your language, you can basically do it. You can even do it in COBOL. Cipher specs is kind of a big one, and actually, you know, a bit of a hot topic at the moment with customers as they are moving to 9.2. So 9.2 is where we started, or we added support for TLS 1.3, which is the most current version of the TLS specification and the most secure. And so as customers are trying to keep, you know, ahead of the hackers, they want to make sure they're using the most secure protocols available, and TLS 1.3 is now available with all MQ and all the clients as well. I should notice that because MQ on zOS requires TLS to be implemented by the operating system, if you want to use TLS 1.3, you have to use zOS 2.4, okay, so it's not available on zOS 2.3. And as well as providing TLS 1.3 support, we've also made it easier to use cipher specs. So in the past, it used to have to, you know, specify a very specific cipher spec, the exact one you wanted to use, and then if you changed it, you had to coordinate the change of that cipher spec on both sides of the channels to make it work. From the 9.2 timeframe, we now have alias cipher specs, which says just use any TLS 1.3 or any TLS 1.2 cipher spec and let the channel negotiate the exact one that's used. And so once you've got that in place, it's much simpler. So if cipher specs get broken for any reason, you can just switch the individual specific cipher spec off, but the alias cipher spec will still continue to work, and we'll just negotiate an alternative available cipher spec. So a very powerful thing. Carrying on in the same area, we have had lots of customers looking at making use of ATTLS with MQ, but because it's something that's entirely transparent, so I should probably step back a bit. So ATTLS is application transparent TLS. It's basically something you, again, define with a policy to zOS, and then applications that kind of match that policy, i.e. use a particular port or IP address, automatically get TLS encryption over their network data. And so, you know, really it's entirely transparent. And that means if you have two zOS queue managers, you can use ATTLS to encrypt the data being sent with them without using MQ's TLS support. And that's great. We've had lots of customers, you know, doing that if they're doing Z to Z connectivity. And it really is, you know, the MQ admin doesn't need to care about it. They delegate that down to their network admins, and they sort it out because they'll have done it for DB2 and Kix and all the rest of it already. The challenge typically comes when you want to connect from zOS to distributed, either from queue manager to queue manager, or, you know, from app into a zOS queue manager, because here you're kind of hybrid. You've got maybe ATTLS on the zOS side, but MQTLS on the distributed side, and that requires a little bit more thought as how to set it up, because on one side you have to have, you know, your MQ configuration, but on zOS you don't. And so recently we've had a number of customers interested in this, and we've now documented it in the knowledge center back to version 9, I think, on how to go and set it up. So I'd well recommend, if you are interested or you've looked at it in the past and not been sure how to do it, then this is something that's fully documented, it's fully supported, and, you know, we provide advice in all these scenarios. What I should say before moving on is that actually, if you do use ATTLS with MQ for zOS, yes, you get encryption of your data over the network, but it does prevent a number of capabilities in the zOS queue manager from working. So, you know, anything that requires mutual auth between MQ and its partners won't work, because that queue manager on zOS now no longer has access to the client's certificate. So things like SSL CAuth or CHULAuth rules that rely on looking at the peer's distinguished name or anything like that won't work. But, you know, maybe that's an acceptable compromise. It's just worth bearing in mind that there are some restrictions, but if those restrictions aren't the problem, and it's the case for many customers they're not, then this is well worth thinking about setting up. And there's also a performance report out there showing how ATTLS compares with MQTLS, and the answer to that is sometimes ATTLS is faster, sometimes MQTLS is faster. It depends exactly what you're doing. Okay, you've got 10 minutes left. So another really interesting area is Ansible. So over the last year or so, the zOS portfolio and zOS itself have been really, really big fans of Ansible. So for those of you that don't know what Ansible is, it's a way of automating the deployment or configuration of your systems. And traditionally it was something that was very common on the distributed side of things. So you would have these things called Ansible playbooks, and the playbook basically describes a set of steps you want to do for an automation task that you want to perform regularly. Install this, run this command, do this to a file, blah, blah, blah. And you have a prescribed set of steps get written in the playbook, which is basically a YAML document. And then you run that YAML document of the playbook on a control node, and the control node goes and interacts with one or more managed nodes to actually go and execute that playbook. And so traditionally, those managed nodes would be Linux, Windows, AIX, things like that. Now, or at least for the last couple of years, you can now have a managed node that's on the zOS side of things. And this is really, really powerful, because what it means is you now have the ability to use one automation tool across your entire set of infrastructure. You have a playbook for performing your zOS tasks, you have playbooks for doing your Linux tasks, and you can automate them from one place. You can, orchestrate them from the same place as well. Because let's face it, right? zOS doesn't sit by itself. It often needs to go and be connected to from a Linux environment or something like that. And so, to make that connectivity happen, you have to do some configuration on the Linux side, and you need to do some configuration on the zOS side. Certainly, you would be doing that if you were setting up MQ. Like a sender channel from Linux into a receiver channel on zOS, you'd have to go and define both ends of the channel. You can do that using Ansible playbooks. You have a playbook that does the distributed side, you have a playbook that does the zOS side. You run them from one place using a single click of the button. Again, you're using repeatable skills because every playbook looks like any other playbook, and it's a really powerful way of doing things. And that obviously doesn't just apply for MQ, it applies for Kix, it applies for IMS, and anything else you want to do. So IBM provides a whole load of useful capabilities for interacting with jobs, playing around with data sets, submitting commands, which is what the MQ sample playbooks do. So it's really, really powerful. So if you are interested, then I'd recommend having a look at the link down the bottom, which shows you the sample playbooks for MQ, or come and chat to me. This is easy to set up. It took a couple of hours to get it running in our environment and actually write those playbooks. So it is really easy to get your head around. And once you've got it, you've got an automated task which you can use for the foreseeable future. Okay, I can't remember how many slides left I've got, so I'm just going to skim over a few things. We've done managed file transfer enhancements as well. So particular things that are relevant to zOS is provided guidance for setting up MFT agents, which are the things that do the file transfer, and have them work and connect to a queue sharing group, giving you enhanced availability. We've given increased advice for how to set up MFT to do data set transfers, because if you do MFT, that's all about transferring files. But of course, when you're running on zOS, you might want to transfer files from USS, or you might want to transfer data sets as well. And we support both. It's just that there's a few corner cases with data sets where there's some restrictions, and we've documented what those restrictions are in a better way, and also how to get around them. Okay, and so that's in the link down the bottom that I provided there. A couple of things on developers. You've probably heard this all before, but there are now a whole load. In fact, we're increasingly adding MQ tutorials on how to use MQ on distributed and zOS and understand what various messaging capabilities are and mean. And this is particularly useful for those new joiners who are coming into teams as teams evolve. So well worth looking at if you haven't already, or looking at it again if you already have. Application development, we continue to keep current with different environments, Java 11 support on distributed, running applications and building applications using Maven or running on Mac, all good stuff there. And also, new styles of applications. REST messaging is becoming very important, and our REST API that we do provide for messaging is growing capabilities, and also we've got various open language bindings on distributed as well. So that's all I had to say. I don't think I spotted any questions in the chat, but thank you for listening. If you do have any questions, then stick them in the chat now, or do feel free to reach out to me. Do remember to fill in your session feedback, because this is session 1AU, and I'd really appreciate any feedback you've got. And I'm hoping the next slide, there you go, has my email address on it. So thank you for listening. I'm Matt Lemming, architect for MQ for zOS. If you do want to come and talk to me, you don't want to put anything in the chat, then please feel free to email me, because I get lots of emails from customers. I'm more than happy to chat about anything I've covered today or anything else, MQ related, zOS related, or anything else. So thank you for listening.
Thank you very much, Matt. That was a really good presentation. And thank you to everyone who's attended.